In our next group of problems, we're going to use this fact that a raised to the negative n is going to be equal to 1 over a to a positive n. So let's move on then to example 3. So we have 5 to the negative 2. So that would be written as 1 over 5 to the positive 2, which is going to be 1/25. If I have negative 4 raised to the negative 4, so this is whole parentheses raised, then that's going to be 1 over the parentheses negative 4 raised to the positive 4. So then this next one would be, okay, so here in C, you notice that the negative 3 exponent is just with the x. So the 2 will not be changed, but the x will become 1 over x to the positive 3. And so this then is going to be 2 over x to the third power. D, I have the parentheses raised to the negative 1. So it's going to be 1 over, and then the parentheses to the positive 1 power. So we don't really need those parentheses, so 1 over 3x. Here, I have a quotient rule, so this is going to be m to the 5 minus 15, which is going to be 1 over, I'm sorry, I got ahead of myself, so this is going to be m, whoops, that's not going to work, is it? Thought it might. This is going to be m to the negative 10, and then that would be rewritten with a positive exponent as 1 over m to the 10th. Then f, I have 3. The base is 3, and then my exponent on top is 3. Subtract the denominator exponent. So then that's going to be equal to 3 to the negative 3, which then becomes 1 over, to change it to a positive, 1 over 3 to the positive 3. And then that's going to be 1/27. 3 times 3 times 3 is 27. Now here, I have 2 to the negative 1, so that's 1/2 plus, and then 3 to the negative 2, which is 1 over 3 squared, and 3 squared is going to be 9. And then I need to finish that up by adding them, so I need a common denominator of 18. And so 2 will go into 18, 9, that's 9/18. And then this is 2/18, and add them, and my answer is going to be 11/18. And then finally, I have 1 over t to the negative 5, which in the denominator now, I have my negative exponent. So that's 1 over t to the positive 5. So this line means to divide. So I got 1 divided by 1 over t to the positive 5. And then with fractions, you change to multiplication of the reciprocal. So then you get this t to the 5th over 1. So t to the 5th over 1, of course, is just t to the 5th. Now that's a long way to go, but notice that 1 over t to the negative 5, what happened to my my t is it bumped up to the numerator here. It bumped up to the numerator and became positive. So we're going to note here in our helpful hint that when a factor containing an exponent is moved from the numerator to the denominator, or from the denominator to the numerator, the sign of its exponent changes. So here x to the negative 1 is going to be, x to the negative 3 is going to be 1 over x to the positive 3. 1 over y to the negative 4, it's going to move up and become y to the positive 4. And here, my a to the negative 3 moved to the denominator is positive 3. And then b to the negative 5 is going to move to the numerator as b to the 5th. So we don't have to do all this work that we just did right here to correct that. All right, so example 4, simplify and write with positive exponents only. So let's think about that rule that we had. All right, so here I have a negative exponent, so it's going to need to move to the denominator as x to the 9th. And my x squared is still down there, so these are actually multiplied. and it's in the denominator. I've got to have something in the numerator, so that's a 1. Now I've got these two multiplied, so it's going to be x to the 9 plus 2 in there, and that's going to be 1 over x to the 11th. Here I have 5 p to the 4th, and the p to the negative 3 is going to move up to the numerator and become p to the positive 3. So then that's going to be 5p. They got the same base, so I'm going to add the 4 plus 3, and that's going to become 5p to the 7th in simplified form. Here I have a base of 2. My 2 is just the same as a variable base. It's a base. However, I notice that I have 2 to the negative 3, so that's going to move across the fraction bar, become positive 3. And my 2 to the negative 1 is going to move up across it and become 2 to the 1. So now I'm going to do my quotient rule. So it's going to be 2 to the 1 minus 3. And that's going to be 2, the negative 2. 1 over 2 squared, so that's going to be 1/4. You know, truthfully, you could have just subtracted here too and done 2 to the negative 3 subtract negative 1. So you could have skipped some of these steps in there if you had done that. Maybe we'll find another one where I can do that. All right, so here I've got my 2 and my 10, so that's going to reduce by 2, so that's a 1 and that's a 5. So I have a 1 and a 5 here. And then let's do this with the x. Okay, now I'm going to do this. See, I have the same basis here with my x's. So that's going to be negative 7, my numerator 1, minus my denominator 1, which is positive 1. And then y, I have my numerator 2, and subtract the denominator, which is negative 5. So minus and minus is going to be plus 5. So then I'm going to have x to the negative 8, y to the 7th over 5. And finally, I can't leave a negative exponent, so I'm going to, because it's negative, drop it. And I have y to the 7th in my numerator, because that was positive, and then in the denominator 5x to the 8th. On example E, we're going to do I'm going to do the multiplication first. So I will have, I'll do it underneath it, 3, and I have x to the negative 3 plus 2 over x to the 6th. So that's 3x to the negative 1 over x to the 6th. Now I'm going to combine my x's using the quotient rule. So I'm going to have 3x to the negative 1 minus 6. So that's 3x to the negative 7. And now I need to eliminate my negative exponent. So my 3 doesn't have an exponent, so it remains in the numerator, and then my x to the negative 7 drops and becomes positive 7. Now finally, we've got these examples here where we're going to do the same rules. So I have a base of x, my exponent of 3a plus 4. And then here I'm going to use my quotient rule. So my base is x, and I have 3t minus 2. And I'm going to subtract this exponent, which is t, minus 3. And I'm going to put in parentheses because I want to subtract the whole thing. So then that's 3t minus 2 minus t plus 3. Minus and minus is plus. So x to the 3t, oh, it's 3, should be 2t. I'm going to combine terms. 3t minus t is 2t. And then negative 2 plus 3 is plus 1. Now we have no idea whether that's positive or negative. So we're not going to do anything past that point.